In this video, we are going to discuss cumulative distribution function or CDF. This one for continuous random variable. Cumulative distribution function is represented by f, capital F of x equals probability x less or equal a is equal to integrate from negative infinity up to x for the function f of t with respect to dt. For probability x less or equal than a is equal to f cumulative f of a. For probability x lies between a and b included is equal to cumulative f of b minus f of a. Let's say number 9. We want the region A to B. Probability A, x lies between A and B. This region. We want this region A to B. So for cumulative FB from negative infinity up to B minus FA from negative infinity up to A. So the pink region minus the green region. So we want this region. Okay. Median is probability x less or equal n is equal to 0.5 or cumulative up to m is equal to 0.5 from negative infinity to m. This region is equal to 0.5. The probability is equal to 0.5. And then you present the probability x less or equal m or cumulative f of m is equal to 0.5. And find m. M is a median. Example, a continuous random variable x has probability density function given f of x, a function piecewise function, this one, obtain the cumulative distribution function f, capital F of x, sketch graph of f, find probability x greater than 1 and find probability x lies between 1 and 5. Determine the median m. So to find the cumulative distribution function, from the piecewise function, it is better for you to transfer to number line. So we have 1, 2, 2 region. Okay, 2 region and plus add on another 2 region, 0 and this on the left hand side and on the right hand side. Okay, so this is the number line from negative infinity to infinity. Okay, this is the region. Okay, the region. To find the cumulative when x less than 0. This is included, exclude. So from negative infinity up to 0, exclude. Okay, and the formula is fx is equal to integrate from negative infinity up to x ft dt. This is the formula for cumulative. So fx integrate from negative infinity to x, function is 0. Okay, respect to t. So answer is 0. 0. For this interval from x lies between 0 to 2, to find the cumulative, still we use the same formula. We need to integrate from negative infinity to x ft respect to t. So from here, fx is equal to f0. Okay, from negative infinity up to 0 here, f0, right, f0 to here, plus from 0 up to x. 0 up to x, here means that x is somewhere between 0 to 2. The function is 1 over 16x. Sorry, 1 over 16 t, t respect to t. Okay, we use parameter t. Okay, then this is 0 plus, okay, integrate t squared over 32. And, okay, substitute the limit from 0 to x. Then the answer is 1 over 32 x squared. This is the region. From negative infinity up to x. From negative infinity up to x. Let's say x is here, somewhere here. From negative infinity up to x. Okay, means from negative infinity up to 0. Okay, here, f0 is 0. Plus 0 to x. 0 to x. Okay, we take the function because of this x lies between 0 to 2. And change to t because of use variable parameter t. Okay. And the next step, the next region, we need to find fx, use the formula from negative infinity, the same formula, ft dt. Okay, here is from negative infinity up to x. X lies in this region from 2 to 9. So, from negative infinity up to 2, f2 plus 2 to x. X lies within this region. Take this function 1 over 8 respect to the t. So f2 is from here. Okay, substitute here. 1 over 32, 2 squared plus 1 over 8t. Okay, limit from 2 to x. Substitute 1 over 8 plus 1 over 8 x minus 2 and simplify 1 over 8 x minus 1 over 8 or is equal to 1 over 8 x minus 1. Okay. The last part. Okay, when x greater than 9 included. Why included? Because of in this region 2 x lies between 2 include to 9 exclude. So we take 9 onwards. Okay, including included. So the same formula fx equals integrate from negative infinity to x ft dt. So x is okay, from negative infinity to x, from negative infinity up to x. This is x. X lies within this region. Okay, choose the color. Okay, here is from negative infinity to 9, f9 plus 9 to x. 9 to x, the function is 0 respect to t. So f of 9, take this function, substitute 1 over 8, 9 minus 1 plus this is 0 is equal to 1 over 8, 8 is equal to 1. Okay, for cumulative distribution function, make sure starting by 0 and end up with 1. So we need to represent the answer in function fx. Okay, starting with 0, 0, when x less than 0, 1 over 32, 1 over 32 x squared, when x lies between 0 to x lies between 0 included to 2, and this function 1 over 8 x minus 1, when x lies between 2 to 9, then 1, when x more than 9. 1 when x more than 9. So this is the function cumulative distribution function for continuous random variable. Okay, to sketch the graph of f, check the domain. Where is the domain? Okay, 0, 0 to 2, 2 to 9, 9. So first is, okay, try to exist x, y, 0, 0 to 2, 2 to 9. Okay, for 0, x less than 0, function is 0. So this is 0. 0. Okay, for the second one, substitute 0, substitute 2, 4, 4 over 132, 1 over 8. So 0 to 1 over 8, this is curve, quadratic. 0, and when x is equal to 2, y equals 1 over 8, curve. Okay, you have to do curve, quadratic. Okay, yeah. And then, and this is exclude, but here this is continuous, that the graph is continuous. Okay, so 2, substitute 1, 1 over 8, then substitute 9, 9 minus 1, 8, 8 over 8, 1. This is linear. Okay, so let's say this is 1, linear, 9, 1, straight line. Okay, then when x more than 9, the graph is flat line, y equals 1. Okay, so you have to show the graph from negative infinity up to infinity. The graph up to infinity, the graph is continuous. Okay, this is the graph f. Okay, fx. Next is find probability x more than 1 and x less between 1 and 5. Okay, we use this one, and this cumulative. Okay, for cumulative, okay, you have two methods. Maybe you can use here this function to find this probability, but now we're going to use cumulative to find the probability. X more than 1. Okay, so if you do number line 1, more than 1. So we want this region more than 1, but to use the cumulative, it should be start from negative infinity up to 1. So all the probability actually 1, 1 minus this part. This part is F1. Okay, 1 minus P probability x less or equal 1, or 1 minus F1. Okay, find the value of f of 1 from the piecewise. Okay, so 1 lies between this interval 1. We take the function 1 over 32 x squared. Just substitute 1 into this function 1 over 32 x squared. So 1 minus 1 over 32 x squared means that 1 squared. 1 minus 1 over 32 is equal to 31 over 32. Okay. Then to find the probability, P probability x lies between 1 to 5. Okay. So between 1 to 5, 1, 5, between 1 to 5. Okay, if you want to use cumulative, means that you have to take from negative infinity to 5, F5 minus from negative infinity up to 1, F1. So F5 minus F1. Okay, from the piecewise function, F5 lies in this interval, means I just take this function, substitute 5. And 1 lies in this function, take this one as a function. So substitute 1 over 8, 5 minus 1. 1 over 8, 5 minus 1, minus 1 over 32, 1 squared. So 4 over 1 over 2, minus 1 over 32, and is equal to 15 over 32. Okay. Okay, the last part is determine the median. Median. Okay, for median, f of m equals 0.5. Okay, you have to check. This is 0. Let's say substitute 2 here. F of 2 is equal to 2 squared over 32 is equal to 4 over 32 is equal to 1 over 8 or 0.125. This one is less than 0.5. So we can conclude that the median lies between this interval. Okay, because when the maximum number here, you substitute inside here, you give the answer 0.125 probability. So less than 0.5. we need to conclude that M lies between 2 and 9. So, median of M suppose lies between 2 and 9. And take this one. F M equals 0.5 and substitute 1 over 8 M minus 1, substitute M here, is equal 0.5. And M minus 1 is equal to 4. Therefore, M is equal to 5. And check, 5 lies between 2 and 9. So the answer is 5.